Alright, so we're left here after simulating our model, and the last thing that I want to show you before we move into the projects is how to add a MATLAB function into Simulink. So sometimes the blocks that are included in Simulink don't necessarily perform the exact function that you might want it to perform. Or it might be easier to just write a code, or rather a MATLAB function that performs a certain function that you're trying to perform. So Simulink gives you the flexibility to add a MATLAB function inside Simulink as a graphical block. So what I want to do is I want to show you how to add a MATLAB function, and then we'll go over how to define that function and how to add some code, and then we'll see how that interacts with the Simulink model. So if you go to your library browser, you can do a search here in the search bar for MATLAB and just do search, and you'll see this block over here, which is called again a MATLAB function. So you see here in the description that it says select the settings for the subsystem block to enable parameters for code generation, select treat as atomic unit, and then if you go here to the help menu, we'll see the documentation for that block. And so you see here in the description that it says with the MATLAB function block, you can write a MATLAB function for use in a Simulink model. The MATLAB function, you create executes for simulation and generates code for a Simulink coder target. If you're new to Simulink and MATLAB products, see this help documentation. So basically what this is you can essentially write code, as you can see over here, in a MATLAB function, and then that also is going to interact with the Simulink model. So let's go back into our Simulink model, or actually let's go here to the library browser and let's add that to our model. So again, we can right click on this, add block to model, sample model. And so I renamed the model that we've been looking at previously, and I called it the sample model, and I'm going to make it available for download with the lecture resources. So now if we go to our model, then you can see that the MATLAB function is in here. So you can see here that it has an input U and an output Y. So essentially we're going to feed an input to the MATLAB function, and then we can perform whatever we want over that input, and then we can feed that to the output, and then we can use the output within the Simulink model. So what I want to do first is I want to simply just replace this gain function. So essentially remember that we were taking the simulation clock time and multiplying that times 5, and then we were feeding that into the voltage source over here. So what I want to do is essentially replace this gain with a MATLAB function, just to show you how we can use the MATLAB function, and then we'll do something a little bit more complex. So let's put this MATLAB function in. So essentially again, we're going to feed the clock into the MATLAB function, and then we're going to take the output of that MATLAB function and we're going to feed this to the control signal. So if you double click on the MATLAB function, you're going to get this. So this is the code that is inside that MATLAB function block. And you can see here that we have function y equals function of u, where u is the input, and then it's predefined before we make any changes as y equals u. So it's basically just a straight pass through. The output is going to be the same as the input. So in our example previously, we were taking the clock time, or rather the simulation clock, and multiplying that times 5, and then we were feeding that into the control signal. So to mimic that, what we can do here is just simply multiply the input u times 5. So very straightforward. Again, u is the input to the MATLAB function, and then y is the output. And if we're trying to replace the gain block that we were using previously, which was just a simple gain of 5, we can simply just take the input u, multiply that times 5, and then we'll set the output y equal to that. So we can actually run the model from here. So let me go ahead and click run model, and let's actually go back here to the scope. So you see here on the bottom that it says compiling, and now it's going to execute. So now we've run the simulation. Let's see what the scope looks like. And this looks exactly like what we saw before. So the top trace again is the voltage, bottom trace is the current, and you can see that the voltage is basically 5 times the simulation time. So we're running our simulation for 3 seconds, and I can see then that at t equals 0, the voltage is 0. At t equals 1 second, so this time over here, the voltage is equal to 5. At t equals 2, we get that that's equal to 10. And then at t equals 3 seconds, that's equal to 15. Again, this is exactly what we saw in the previous lecture, because again, we simply just replaced the gain function, or rather the gain block, with a simple MATLAB function that is doing the same thing. So it's multiplying the input times 5 and then feeding that to the output. Now, of course, the nice thing about the MATLAB function is that now you have the flexibility to do more things. So for example, I can say 5 times u plus 1, for example. So we can run the model again, and let's see what we get. So of course, we start at 1 now, so 0 plus 1, and then we end, instead of ending at 15, we end now at 16, so 15 plus 1. So again, pretty straightforward, but you can also do more complex things. So for example, I can say 5 times the sine of u plus 1. So we're going to take the sine of the input, multiply that times 5, and then add 1 to that. So you can see here that we can, with MATLAB code, do a much more complex function than what we were doing with the Simulink blocks. Now you could do the same thing with Simulink blocks. You could still find a sine function in the library browser, feed the input to that, then take a gain block, feed the output of the sine block to the gain block, and then also add 1 with a constant and an addition block. But it would be much more convoluted than just writing some simple code to do the same function. So that's the nice thing about having a MATLAB function inside a Simulink model. When you're trying to do more complex stuff, it comes in handy to just be able to just write some simple code. Here we basically just have one line of code that is essentially replacing 3 things if we were going to do it with a Simulink block. So if we were doing the same thing with Simulink blocks, we would have to take the input, we would have to have a sine block, then a gain block, so that we can do times 5, and then an addition block where we would add 1. So if I go to the library browser, for example, we would essentially have to do, if you go over here to commonly used blocks, we would essentially have to do an addition to add 1, a multiplication to multiply times 5, and then we would also have to do a sine function. So I can search here for sine, essentially this. So we would have to take the input, and then this would give us the sine of the input, and then we would have to combine that again with both a gain block, which would give us the times 5, and then an addition block or sum block over here, which would add 1 to that. So we would have to have 3 blocks for something that we can easily do with just some simple code in a MATLAB function. So that's the nice thing again about a MATLAB function. When you're trying to do multiple things, and it would just be easier to just write some simple code rather than having to add many blocks to the Simulink model, you can just simply do it with a MATLAB function. So I just wanted to show you how to do that again. Let's say that we wanted to add that now, or rather run that model. So we're going to take the sine of the input, multiply it times 5, and then add 1 to that. And again, we can run that from here. And let's go back to the scope now. And you can see that this looks sort of as a sine wave. And if I change the simulation time, let's do something a little bit longer. So 20 seconds, for example. And let's run it again. We can go over here to the scope. Now you see that the voltage, because now we're feeding this sine function to the controlled voltage source, now the voltage is actually a sinusoid. Again, we would take in the sine of the input times 5 plus 1. That's why you see the peak of the sine wave over here at 5, and the positive peak, that is, and the negative peak at -4, because we're shifting the sine wave 1 into your output. So again, I just wanted to show you that you can do this. You can add a MATLAB function to a Simulink model, and sometimes that simplifies the model. Some you can just write some simple code in a MATLAB function and then have that interact with your Simulink model.